Okay, we're going to take a look at our next lesson, applying the properties of operations to add and subtract rational numbers. We've probably started this topic already in class, so in case we didn't get through all of it, this is just to finish up that discussion. So you can fast forward to any part that you need to, or listen to this whole thing again. All right, so we talked about our main premise is the opposite of a sum is the sum of its opposites. So we're going to be taking a look at this particular statement. And so I probably asked a couple of you to come up with numbers and their opposites. So let's say that we take two of those, and let's say the two numbers that we pick are 7 and minus 2. Okay, so 7 and minus 2. Well, if we add 7 and minus 2, we are going to get a 5. Okay? Now, the opposite of 5 would be minus 5. Okay? Now, let's say we took those two add-ins, the p and the q value, and let's say we take the opposite of it. So the opposite of 7 would be minus 7. And the opposite of minus 2 would be positive 2. And if we add those two together, a minus 7 and a positive 2, we get minus 5. So notice that these two numbers are the same. So that's where the opposite of a sum, here is our two original numbers, and here's the sum. This is its opposite, is the sum of its opposites. So if I take the opposite of those two add-ins, or the p and q value, then I get that same opposite number. So we're taking a look at that statement of an opposite of a sum is the sum of its opposites, because we can use that fact to help make problems a little bit easier to solve. So for our first example, let's take a look at this rational number, negative 2 and 2/5 plus 3 1/4 minus 3/5. And we're going to solve this two different ways. First, we're going to keep everything the same, and we're just going to go ahead and solve it from left to right. Now, if you remember correctly, the first thing we need to do is come up with a common denominator. In this case, it would be 20. So we're going to rewrite this as negative 2, and 4 times 2 is 8/20, plus 3, and we're going to make that 20, so 5 times 1 is 5, minus, we have 20ths here, and 4 times 3 is 12. So now we have minus 2 and 8/20 plus 3 and 5/20 minus 12/20. And what we can do here is we can go ahead and put these together. So minus 2 times 20 is 40, and this would be 48. So this would be minus 48, 20th, plus 3 times 20 is 60, plus 5 is 65, 20th, and minus 12/20. So if we put these two together, a minus 48 and a positive 65 is 17. Actually, it's not 17. Let's see, 48. That would be, oh yeah, it's 17. Okay, yes. All right, so 17/20 minus 12/20. And then from this part, 17 minus 12 is 5. That's 5/20 or 1/4. All right, now let's try this a different way by maybe putting some things together. So we're going to start off by moving some things first. Remember, we can't move this unless we turn this into an addition problem. So I'm going to rewrite this as minus 2 fifths, 2 and 2 fifths, plus 3 and a fourth, plus a negative 3 fifths. So once I've done that, now I can put numbers with the same sign together. So I'm going to use my commutative property to move the minus 3 fifths and do that. So notice it's kind of nice that minus 2 and 2 fifths plus a minus 3 fifths, well, these already have a common denominator, and 2 and 3 would be minus 5, and therefore we have minus 2 and 5 fifths plus 3 and a fourth. Well, minus 2 and 5 fifths is minus 3, plus 3 and a fourth, and 3 and minus 3 is cancel each other out as 0, so we're left with 1/4. So in this case, I didn't even have to come up with a common denominator. But notice that both methods end up with the same result. It's just this might have been a little bit easier because we didn't have to come up with a common denominator. All right, let's go ahead and take a look at the back side of that. So for example 2, a mixed number is a sum, and we're still going to use that statement of the opposite of a sum is the sum of its opposites. So if I have 2 and 2 fifths, as it's asking right here, how would I write that as a sum? Well, the opposite of 2 and 2 fifths is minus 2 and 2 fifths. So how can we show that? If 2 and 2 fifths is the same as 2 plus 2 fifths, then the opposite of that would have to be that this would be a minus 2, which is right here, minus 2 plus a minus 2 fifths. And that's what this is saying. If I take 2 plus 2 fifths and then take the opposite of that, it's the same as minus 2 and 2 fifths. So here I can write this as the opposite of 2 and 2 fifths. So this is the same thing right here. Minus 2 plus a minus 2 fifths is the same as 2 plus 2 fifths, and then take the opposite of that. And that's illustrated right there. So let's see if we can use that to our advantage. And we're going to do exercise 2. So what you're going to do is, if we haven't already done this, you're going to pause the video and try each of these. You're going to rewrite each of these mixed numbers as a sum of 2 signed numbers, and then go ahead and restart the video and check your work. All right, so you should have had minus 9 plus a negative 5/8. Here would be minus 2 plus a negative half. And for this last one would be 8 plus 11/12. Now again, you can also think of this as the opposite of 9 plus 5/8 and put the opposite on the other side of that. So this one over here would also be the opposite of 2 plus 1/2. So I can add these two together and then just take the opposite of it. All right, on the next page, exercise 3. What you're going to do, again, is stop the video and represent each sum as a mixed number. So we're just going to reverse the process. Once you are done with these 3, go ahead and start up the video and see if you got it right. All right, so if I'm going to add 1 plus a negative 5/12, that is the same as minus 1 and 5/12. 30 plus 1/8 is the same as 30 and 1/8. And minus 17 plus a minus 1/9 is the same as minus 17 and 1/9. And again, to go back to these two, this is the same as saying the opposite of 1 plus 5/12. And this over here is the same as saying the opposite of 17 and 1/9. So either way, however you want to do that, would be fine. All right, for exercise 4, Mr. Mitchell lost 10 pounds over the summer by jogging each week. By wintertime, he had gained 5 1/8 pounds. Represent this situation with an expression involving signed numbers. What is the overall change in Mr. Mitchell's weight? So if he lost 10 pounds, but then he had gained 5 1/8 pounds, how would we represent that? Well, losing 10 pounds would start off as minus 10. And gaining 5 1/8 would be plus 5 1/8. So there's a couple of ways you can go about solving this. Go ahead and try it on your own, and then we'll see what you come up with. All right, so we're going to use what we just got done practicing on. So how can we rewrite this? Well, we can write this as minus 10 plus, and then we're going to split this up using the sum of our opposites. And this is going to be represented as 5 plus 1/8. So now the nice thing is, since we've got this split up, we can deal with the whole numbers. So let's use commutative property, or not commutative, I'm sorry, associative property, to put these together and evaluate this. So what is minus 10 plus 5? Well, that would be a minus 5, and then plus 1/8. Now, don't throw these together and think it's minus 5 1/8, because this is a minus 5, and then we're adding an eighth to this. So in essence, since this is positive and this is, this is negative and this is positive, this is actually a subtraction problem. If you draw it out on a number line, we went to the left minus 5, but then we're going to the right 1/8. So if I take an eighth away, how many eighths do I have? Well, that would be 7/8. And because I'm starting from 5 and going to the right, it's actually negative 4 7/8. So our final answer would be negative 4 7/8. Another way to think of this part is, remember, minus 4 plus a minus 8/8 plus 1/8. And you can do the kind of commutative property again. A minus 8 and a plus 1 is minus 7/8. And then we have 4 plus a minus 4. Now we can put these together. Minus 4 and a minus 7/8, because they're both going to the left, is minus 4 7/8. So either way you want to do that is fine. Okay, but at least you've got some tools to help you make this into an easier problem. All right, the last page we're going to take a look at is exercise 5. Jamal is completing a math problem and represents the expression minus 5 5/8 plus 8 minus 3 2/7 with a single rational number as shown in the steps below. Justify each of Jamal's steps, then show another way to solve the problem. So again, go ahead and you can just write off to the side what each step is showing. And then for your homework or for the rest of this to bring into the next class, you're going to solve this in a different way. So again, stop the video, go ahead and write out each step that's being done, and then check your work. All right, let's see how you did. So for step 1, if this was the original problem, And now it's been rewritten as this. Notice what has happened. It has been written as an addition problem. So subtraction is the same as adding the inverse. All right, so we've turned minus 3 2/7 into plus a minus 3 2/7. Now, what happened from this step to this step? We used commutative property because we moved the location. Commutative property of addition. Now, what happened in this spot? Well, minus 5 5/7 is split up. Minus 3 2/7 is split up, so this is the sum of the opposites, or the opposite of the sum of the sum is the sum of the opposites. I'll just abbreviate that. All right, after that, now what has happened? Well, we've got some movement again, so we have the commutative property. Commutative property of addition. And what we've done here is we have simplified. We've applied the associative property here. So the associative, we've associated this to get 1. So if you notice, these two equals a negative 1. So we've used the associative property to simplify this. Associative property of addition. And then here, the difference between this step and this step is we've just added. So this is minus 5 plus a minus 1 equals a minus 6, because we've gone from here to here. And then the next step is minus 6 plus a minus 3 is a minus 9, because we have minus 6 and minus 3 is now minus 9. And then the last part was minus 9 plus 8 is minus 1. Okay? So that's how you would list out the steps. And to finish up this particular assignment, you are going to solve this problem again in a different manner. So use whatever steps you want. Obviously, you're going to get the answer of negative 1, but try to see if you can do this in a different way, and that will be our warm-up for tomorrow. All right, see you then.